All right, guys, we are moving on from LCM and GCS. We are moving into fraction operations. Today, we are starting with fraction multiplication. It is something you should have learned in 5th grade, but we're going to go more in depth with it. But first, I want you to plot these 4 points on the given number line. So for number 1, you're going to plot the number 2. For number 2, 1/4. For 3, 4 and 1/3. And for 4, 7 halves. You're going to put them on the number line where they should go. For example, if I had 2 and 1/3, I would go between 2 and 3, divide it into 3 sections, and I know the first one is 2 and 1/3. Make sense? All right, guys, you have about 2 minutes to get those done. Who can tell me where the number 2 goes on our number line? On the actual 2, yes, that makes sense. All right, where would 1/4 go? Okay, so my question is, do we have a whole number with a fraction? So we know that it is less than 1 because there is no whole number. So if it's less than 1, that means it's coming between which 2 numbers? Between 1 and the 0. And since it's talking about fourths, I break it into 4 pieces, 1, 2, 3, 4, and it is 1/4. So I'm putting it at the first one. Does that make sense? All right, 4 and 1/3. You can tell me where that would go. Okay, so he says a little past the 4, between the 4 and 5. So we're talking about thirds, so I'm going to break it into 3 pieces, 1, 2, 3, and I know it goes at the first one because it's 1/3. Make sense? And then I have 7 halves. What do you notice about this fraction? It is improper, so we have to make it a proper fraction first. What do I do to make it a proper fraction? I see how many times 2 goes into that 7. How many times will 2 go into 7?
3 times.
That's 6, leaves 1. So that means 3 and 1/2. So where would 3 and 1/2 go on my number line? Good job. He says I divide the space between 3 and 4 into halves, which is 2 pieces, and that goes on the first one. Any questions about plotting points on a number line? You have questions? All right, turn the page. Okay, it was fun until this didn't work. I'm good at this. Don't start.
4. On this page, we actually want to have 2 different colors for the writing pencil, markers, ink for the drawing, not for the writing. Okay? But everybody has 2 colors available. You got a minute to get them. You don't have them. Make sure you tell the student and grab one. We're going to look at how we can multiply fractions to help you understand the answer that you get. And we're going to use an area model to do it, just like we've done previously. So we use an area model to look for the products to determine factors and to list multiples of given numbers. In that same way, area models can do whole multiplication. We can also use area models to use fraction multiplication. So if I have an expression, 1/4 times 1/2, it's represented in the area model below. So how are the factors 1/4 and 1/2 represented in my model? Anybody tell me? Very good. How is factors 1/4 and 1/2 represented in my model? So which color? 1/4 is what color? Good. So as you saw, okay, so this is kind of the force going up. So going up, we have different force, right? And the 1/4, so it's 1/4, is represented in blue. So blue represents 1/4. And that should make it easy then. You can see, and here's one of the keys in your fraction models, guys. You can only do a fraction model with two of them. We do one fraction vertically and one fraction horizontally. Horizontally, we cut it into half. So the red represents the 1/2. Can everybody see that? Are we good on that? Good. Okay, here's where it gets kind of cool. So what is the product? Describe how the product is represented in the model. So what is the product of 1/2 and 1/4? So in other words, how many of those boxes now have two marks in it, both a red and a blue? So, huh? One of them, right? So one has both red and blue. So guess what that is in my fraction? That is going to be my numerator. Okay? How many total boxes do we now have now that we've split it both ways? Okay. Brandon? Again, how many total boxes do you see? 8 boxes, right? So 8 total boxes. So that is now my denominator. So when I write this as a fraction for the product is now 1/8. So here's why this is an interesting concept. Normally, when you multiply numbers, they get bigger, right? If I take a number like 3 times a number like 8, what do you get? 24, it gets way bigger. But when I'm doing fractions, what I'm saying is I'm actually taking a part of a part. So when I multiply fractions, my number actually gets smaller. Okay? Because 1/4 times 1/2, now it's all the way down to 1/8. So now visually, hopefully you guys can see why that happened. Does that make sense for everybody? You can see why 1/2 times 1/4 is 1/8. Okay, I hope so, because we're going to give you guys a chance to demonstrate it for us, to show us that you know. But before we do it, I want you to get your markers out real quick. We've got another math term. That is an algorithm. Mr. Ken and I are both really big fans of algorithms. Algorithms are really just a process or description of steps you can follow to complete a mathematical calculation. You'll notice most of the lessons we teach, we give you guys some form of algorithm in order to do it. So for example, last 2 lessons we talked about GCF and LCM, right? The algorithm was GCF is on the left, so multiply the numbers on the left to get my GCF. LCM is all of them. We multiply all the numbers on the outside. That's an algorithm. So it started with find the key number 2, 3, 5, 7, take out what you can, multiply what's left. We'll give you a couple more algorithms today dealing specifically with fractions. But right now we're still trying to get it cemented in your mind why these algorithms work. So we're going to give you guys a chance to do this. I'll give you a hint because many of you may struggle to do this without it. The bottom number of the fraction is telling you how much to put it into. Remember, I'm doing it in 2 different ways. So one way you can split 3 ways, one you can split 5 ways. The top number is telling you how many of them to shade in. Okay, so that's why you need your 2 different colors. Use one color for the 3, one color for the 5. And then see if you can find the answer. We'll give you guys about 2 minutes to try to work this around.
So he told you, when you circle them, that the denominators tell you how many pieces you're breaking it up into, yes? So the first denominator tells us we need thirds. So I'm going to go from left to right and make my thirds. So that's 1, 2, 3. That's thirds, yes? 3 pieces. And then my second denominator tells me that I need to divide it into 5 pieces the other direction. So top to bottom, I'm going to make 5 pieces. Yes. Mine aren't exactly even, but imagine that they're even. So our numerators tell us how many of each to shade in. So my first numerator tells me I need 2 of my thirds shade in. Yes? So I am going to shade in 1/3 and 2/3. And then my other numerator tells me 3 of my fifths need to be shaded in. So I'm going to go the other direction and shade in 3 of the 5 pieces I made. Now, if I look at it, how many pieces are double colored? 6 are double colored. 6 have green and red. Out of how many did we make in all? 15. So that is the answer to my multiplication problem. Does that make sense? Yes, Mr. Moore is getting to that right now. Right.
Awesome. I'm glad that someone pointed out that we can actually simplify 6/15. So here's one of the big deals. Whenever we do fractions, we always want to simplify. The nice thing is we've already given you the tools to do that because we've introduced you to your 4 key numbers. 2, 3, 5, and 7. So to simplify, all you have to do is say, okay, I have 6 and 15. Can I write them both by 2? No. By 3? So yes, what you do? 5 by 3 is going to give me 2 and 5. That's 2 of my key numbers, so I now know I'm done. So my answer is 2/5. If you go through all 4 key numbers, 2, 3, 5, and 7, you can't divide them both by any of the 4, then it's in simplest form. Make sense? Okay, so show how the algorithm for multiplying 2 fractions less than 1 gives the same product as the model. Well, we haven't actually given you that algorithm yet, have we? So let's do that. Go ahead and write this into your notes. And it is called multiplying fractions. For those of you that are running a math journal, I personally put it in a math journal instead of notes. That's up to you. Because that way you've got a place you can always turn to and get it. If you do it in your notes, it's going to be a lot harder for you to find if you're just doing it in your book. And the math journal makes it really easy. In order to multiply fractions, this is actually the easiest operation to do when you're working with fractions. Step 1, multiplying fractions, multiply. Top times top. Step 2, multiply. Bottom times bottom. And step 3, one that we'll always do, simplify if needed. But you should always check your 4 key numbers to see if you can simplify or not. So I'll give you guys a minute to write this out. And yes, I do realize I could have used proper math terminology. I should have said numerator times numerator and denominator times denominator. most of you understand when you're looking at the fractions, top, top, bottom, bottom, makes sense, right? Okay, so that's why I did that. There is one additional step we'll add in here in a little bit. We're using. It's actually one of the big disagreements Ms. McCann and I have with female. I love reduction, she does not. So I guess you all know which one is the correct way to do it. You should be looking for reduction. Wow. Okay, now that you have the algorithm, let's actually apply it. So we go back to our original fraction, 2/3 times 3/5. And we can now see, to get the answer, all I do is multiply. 2 times 3 is, 3 times 5 is that our original answer? Yeah. Can I simplify 6 and 15? I divide them both by 3, which is going to give me 2/5. So did our algorithm show what we expected out of the model? So do you feel confident that our algorithm is effective?
Yes.
I hope so. Guys, this will always work. Again, multiplying fractions is the easiest one. You don't have to do common denominators and that other stuff. Really just multiply. Super fast. Okay, let's go to page 36. Okay, rather than go through all of this modeling again, we're actually going to go to, yeah, we did on 36. We're going to actually show you another algorithm, and this is for multiplying mixed numbers. We're giving you 2 algorithms today. One for fractions, the other for multiplying mixed numbers. Now, before I get into the algorithm for multiplying mixed numbers, I'm going to show you something real quick. How many of you are familiar with basketball? Raise your hands. Okay, most of you. So this should resonate. One of the key shots in basketball is something called a slam dunk. So in a slam dunk, what happens is the player is going towards the hoop really quick with the ball. He's dribbling, right? And as he gets close, for the really good guys, he starts somewhere between the free throw line and the 3-point line. And they pick the ball up, and it goes really fast from the bottom. They put it up top, right? And then they kind of hang there, and they float through the air until they get to the rim, and then with real slow, they slam it to the hoop. When we are doing mixed numbers, like 3.5 feet, and turning them into improper fractions, we can call it a slam dunk. Why? Because the first thing we do goes really fast, that first part of the motion underneath. I'm going to multiply 2 times 3. So 2 times 3 equals 6. Then it gets slow. What's our slow operation for that? Plus, adding, right? So 6 plus 1 equals 7. And I don't change my denominator. So when we talk about slam dunk, all we're saying is, first part goes fast, 2 times 3. The last part goes slow. We're going to add the 1. That gives me 7 now. Those two things are equivalent. But in order to multiply mixed numbers, the first thing we have to do is slam dunk to make improper fractions. Yes. I'm sorry? Rip what out? I wouldn't, because then you're going to lose it. I would keep it in the book. So, and obviously, I probably dog ears with page so you can really look back at it. But this is why natural is doing this. It's like that. That's all you know from one spot. Okay, the nice thing is, once I've done my slam dunk, I have improper fractions for all the mixed multiplying, then it's just like multiplying. So I'm going to do top times top, Bottom times bottom. Same as multiplying brackets. One of the big differences for number 3, you're almost always going to need to simplify because that includes turning it back to mixed numbers. Okay? So we always want to get our answer. We don't really want a final answer as an improper fraction. That being said, as you get into more advanced algebra and stuff, we'll just use it here. But for right now, we want to get comfortable going back and forth between mixed numbers and brackets and about five. Okay? So again, the slam dunk, that's just telling us how to turn those mixed numbers into about fractions. Really trigger first, multiply, flow on the top, adding that numerator. And make sure you don't change your denominator. That is top, bottom, bottom, and then your simplify. So what does that look like? Let's do these two numbers, 3.5 feet by 2.5 feet. So I've got 3.5 times 2.5. My step 1, slam dunk. So I'm going to take both of these. I'm going to multiply, then add. Multiply, then add. So that gives me 2 times 3 is 6. Plus 1 is 7. 2 times 2 is 4. Plus 1 is 5. Once I have slam dunked all of the mixed numbers, now I'm just multiplying. 7 times 5 gives me 35. 2 times 2 gives me 4. So turning that back into a mixed number, I'm just going to use my denominator and say, how many times does the 4 go into 35 without going over? 8 times, right? But then I say, okay, 8 times 4 is 32, so how much is actually left over? 3. That becomes 8 and 3/4. That is my answer. Any questions on this process? Yes. I'm sorry? Yes. Okay. And we've done all the math, we did the models to show you that all this works, right? So everybody feel comfortable that this is always going to work? It will, and hopefully you can understand now why. So now we're going to give you a chance to get some practice. We're going to skip that. We go to page 38. Make sure you sign out. Okay, you're going to see that throughout our module. This is our first time we've really seen it so far. But one thing they do a lot of is give you some examples of students and student thinking. If you see a thumbs up, that tells you that the student got it correct. In this case, both CJ and Megan got the answer right. Sometimes you'll see a thumbs down, and a lot of times you'll see that, they're going to ask why they got it wrong. You have to analyze their work. Sometimes you're going to see a thumb up and a thumb down side by side. That's saying we're not going to tell you if they're right or wrong. You need to look at it and tell us if they are. So in this case, what we've got is Megan and CJ. They're both multiplying. Just to give you the background, they're going to make Hawaiian trail mix for other teachers. This is for one batch, how much it makes. So this is all the different things what they need for a batch of this. And they decide this is going to take 3 batches, but they want to find out specifically the number of comfortable almonds. Okay? So they say we're going to do 3 batches, and when I look at the almonds, I can see it takes 2 1/3 cups for each batch, right? So in order to figure out how many almonds they need, they're going to multiply those 2 numbers. Megan says, okay, well, if I'm going to multiply any whole numbers in order to turn into a fraction, I'm going to put it over 1. For my mixed number, 2 1/3, I need the slam dunk. So I'm going to do 3 times 2 and then add the 1. So 3 times 2 is plus 1 gives me 7/3. So she now has changed it. She said 3 over 1 times 7 over 3. Now I just multiply top times top. 3 times 7 gives me 21. 1 times 3 gives me 3. And then she now needs to take the 21 over 3 and simplify. The 21 divided by 3, it goes 7 times. So the answer was 7 cups. That makes sense for everybody. Okay? Now here is where Miss McShann and I kind of disagree a little bit. She wants you to do this every time. I would prefer keeping it easy for you. Okay? So once if you look, CJ went through the exact same process, right? He started with 3/1. He did the slam dunk, got the 7/3. But then he said, hey, wait, if I look at this, I have a 3 on top in my numerator and a 3 on the bottom in my denominator, don't I? So he does what we call reduction. So for reduction, I need same factor. Anybody want to guess what number to check? I didn't hit the 4 of them. Brandon?
2, 3, 5, 7.
Good. 2, 3, 5, or 7. In both numerator and denominator. So I've got to have one on top and one on bottom for this to work. But if I do, I can actually reduce those numbers out of my expression to make the math easier for myself. So in this case, he said, okay, I've got a 3 on top, 3 divided by 3 is 1. I have a 3 on the bottom, 3 divided by 3 is 1. So I can make both of those 1. So now when I'm multiplying, I just do 1 times 7 is 7, 1 times 1 is 7/1 is just 7 cups. Does that make sense to you? He said, and you know, this part didn't make sense. Okay. Guys, and this is Andrew's making a great point. If you don't understand that, you don't have to do it. Did they get the same answer? Yes. But the difference is she's multiplying all the way up to 21. How far did he have to multiply to? 7. So if you don't do reductions, you're going to have a lot bigger number. And that's what worries me. Once you start getting into numbers like 14, 28, the bigger the numbers you get, the better the reductions work for you. Because otherwise, the math can get really, really complex. So if you do reductions, if I find those common factors, 2, 3, 5, and 7 in the top and bottom, your numbers are going to be good. Actually, your answers are always going to come out in simplest form. The only thing is you might need to switch it into a mixed number. Or you're not going to have to do any additional reductions for it. Okay, so that makes sense. Let's give you a chance to get some practice in. So we're not going to worry about number 2 because we're down to about 15 minutes. We're going to let you guys do number 3. So calculating product, write your answer as a mixed number. You got 2 parts, which are basically just what we went through, how to solve, how to write it, and do the mixed number. So you guys have 17 minutes left in class. Still need to go over homework. I'm going to give you the answers. We can give you guys about 10 minutes to try to get all 6 of these done. See how much of you can do. You can work together at the table if you want to. Okay, guys, I'll apologize. I've already had a couple parents say I might want to slow down, but we got 3 minutes to get through this. I can do homework. I can do that quick. You've been working on it for 12 minutes, so this should be just checking what you've done. So again, we start with a slam dunk on both numbers. 2 times 2 is 5, 15, 17. Here's why I like reduction. If I do reductions, I've got a 5 on top and bottom. Now it just becomes 1. So that means I'm just 1 times 17 is 17. 2 times 1 is 2. 2 goes into 17 8 times with 1 left over. Could have been 8.5. If I didn't do my reductions, I have to do 17 times 5, then divide it by 10. Oh, it's over here. It's probably still picking it up. But thank you though. Okay. Next one, 3 times 2 is 6, plus 2 is 8. 4 times 4 is 16, plus 1 is 17. Again, I have reduction. 4 on the bottom, top, I can divide both of those by 4. Gives me a 1 and 2, so now I just have 34 and 3. That's going to go 11 times with 1 left over. Okay? 4 times 1 is 5. 4 plus 3 is 7. 5 times 2 is 10 plus 2 is 12. I have a 4 on the bottom. I can divide both those by 4. It gives me a 3 and a 1. So I have 21 over 5. It's going to go 4 times. 1 left over. 1 times, 2 times 1 is 2. Plus 1 is 3. 5, 6 is already in simple form. I have a 3 and a 6 I can divide out. Get the 1 and a 2. That becomes 5/4 or 1 and 1/4. 4 times 3 is 12, plus 3 is 15. Whole numbers. Again, if you have a whole number, you have to put it over 1. In order to multiply fractions, both numbers have to be fractions or improper fractions. And now I have a 2 and a 4. I can divide both those by 2. That gives me 15 over 2, or 7 and 1/2. 16 plus 5 is 21. 21 over 8 times 3 over 1. In this case, I don't have any reduction. 8 is the only number on bottom I can reduce. Remember, I can't do 3 and 21 because they're both on top. That's a really key factor if you're doing reduction steps. So 3 times 21 times 3 gives me 63. 8 times 1 is 8. So that's going to go 7 times this. At least you got all 6 of them right. 5 is not bad. No, that's really not bad. Okay. All right, guys, please quiet down. I need everybody to go to page 41. Go ahead and tear it out. Here is your homework for tonight. Oh, no, I did not. Okay, guys, this one should be easy because I literally gave you the algorithm. So you can look at the algorithm, just put it into Word. Okay? On this one, and I don't know why this one causes so much trouble, but I remember this. So she got an exercise that through 20 cycles running, they show the distance of each. So if she does it each day this week, how many days are in a week? 11. What should I be multiplying by? 11. And it's just the swimming. Sure you use the right number. If you complete the routine each day this week, how many times will she cycle? So, use just the number. Okay? Do I need the amount of running? No. I don't know why students feel they need to do it. If they don't ask it, then you don't have to do it. Okay, putting that in rectangular side is rectangular yard. Measured 6 1/5 meters by 8 1/3. What is the area of the yard? Do not forget, anytime we are doing area, I must have units, and my units must be squared when I finish. Make sure you have the proper units. Number 3, there's 3 through 8. All you're doing, calculating the product, show your work. Don't forget the slam dunk. Whole numbers need to go over 1. And make sure you simplify your answer in the end. Number. Guys, real quick, because we're about to hand back your quizzes. If you're doing your quiz, don't like your score in your Google Classroom, I'll show you where it is. Under the math help, there's a test correction form, or you can pick it up from Mr. Tanner on it. Put your name, your assessment. This was quiz 1. Your due date. This is A day. You guys are doing 2 weeks. So your due date is 9/26. B day will be 9/27. You put your original grades. You don't put anything in. Those are for Mr. Tanner and I. There's only 2 questions. So, number 1. I can tell you the most common was students didn't put it in exponential form. So didn't put the right form. So your work, so if I got the answer, put your new answer. You do that for every question. Staple the quiz to the back of the correction form. Correction form on what quiz 9. Have to be stapled. We don't know what all you missed. Okay, we'll do it in 2 weeks. I'm going to hand out your quizzes now. Good luck, guys.